Hi, a friend of mine asked would I be to have a look at this underfloor heating smart thermostat. And what he said was, he says when it's powered up, the display was flickering and I don't think it was responding properly or something, I think he said. So let's power it up and let's see what it's doing. So let's have a look on the back of it here. So it takes mains in on these two contacts here. I'll just zoom down a bit so you can get a closer look. So on here, and these are the outputs. So I'll just get a mains lead, we'll couple some power up and then we'll see what it's doing. Just grab a screwdriver. Right, I'll just plug this in. Oh, it's doing something. Let's just zoom down a little bit. I think it'd be better if I turn this light off for now. There's a little button on the bottom here. But it doesn't appear to be doing anything out of the ordinary at the moment. So what he said was this display was kind of flickering on and off a bit, so it might take a while for the fault to show. Right, I'll leave it on test for a bit and then we'll come back to it if the fault develops. Right, so I've left it on for a while and now we don't have anything on the display. It just seems to have stopped working totally. I'll just zoom out a bit. Let's just see if I get power. So the volts AC. Let's check we've still got power going into it. — 248 volts, 245. So it's definitely still got power. I'll just try switching it off and back on. So we shouldn't have power there now. Let's just try switching it back on. And we don't have anything now. Right. I shall put the light back on. No, that's actually... that was weird. It actually just lit up for a moment there. And it's gone off again. Well, it definitely seems to have an issue, and we've definitely seen it not working correctly, so I shall just unplug it again, and let's have a look. So, let's unplug these two wires. Well, I suspect it's going to be something with the power supply, which I presume is going to be in here, so let's take this part apart. I'll just zoom down a bit. Right, what have we got in here then? So a lopto isolator and a bridge rectifier by the look of it. And there's a space for a unpopulated IC. I don't know if that's for some kind of measurement perhaps. So I did see there was something in there for like an energy monitor feature, so I'm just wondering if possibly that's what that might be. Let's see if this will come out. And what have we got in here then? Well, I can see 3 electrolytic capacitors, which are rated for 85 degrees. I would have thought there would have been 105. Especially with this being in a confined space and put into like a wall back box on a wall, because that's what it's designed to be fitted. So I'm just wondering whether one of these electrolytics has failed. I think that's going to be my first port of call, so let's see how these come out. That looks like they're kind of glued in place. Let's just double check to see if we've got any power in any of these first. I probably should have done that earlier, but... Oh, we're a little bit in there, about 12 volts. So I think it's those two pins there. Let's put the iron on. Trying to see where those pins actually go. That might be the two just before it there. They might be the transformer ones. Yeah, I think it's those two pins just before where I was soldering. Let's see if that'll come out now. Right, I'm just going to get some solder wick. And we'll just clear these two holes up. Right, so I think I'll try my new Peak Atlas ESR 70 Gold. So let's just zoom down a bit. And this is supposed to be 22 microfarads at 100 volt. And it's 21 microfarads with an ESR of 0.57. So I'd say that seems okay. So not that. It looks like the other two capacitors are 400 volt ones. So it might not be capacitors. We'll just pull those ones out and we'll check them in anyway. It's quite compact, this. It's a bit awkward to get this capacitor out. I think it's stuck with the glue. Right, so this one's 400 volt at 4.7. And again, I think that's not too far off. Right, so one more capacitor across here then. And I wouldn't have thought it was going to be that one either. I would have thought there would have been a capacitor on the output side of it. Unless they've got some underneath this heat shrink, I'm not sure what's under there. I wonder if there's capacitors under here. Let's just see which way this goes in again. Right, so the power comes in here. But obviously we don't know where the power comes out, it must be on that connector there. I wonder if they've got capacitors underneath this heat shrink. That's the only thing I can think, because there should be some output capacitors, and that one seems a bit of an unusual value for an output capacitor, especially if it's 22 microfarads at 100 volts. I wouldn't have thought there was going to be 100 volts coming out if you had to drive some little processor and whatever. So we're going to have a look inside of this heat shrink. Here we go. That's more like it. I'll just zoom down a little bit. Yeah, 16 volts, 100 microfarads. And there's two of them. Right, let's pull those ones. I'm just going to add a bit fresh solder. Just going to get solder wick, I think. Let's get this last one out. Again, I don't think that looks too far off. Let's just try this other one. Again, not too far off. Let's check what these probes on properly. Are these crocodile clips? Yeah, not too far off at all. So let's see what else is on this circuit board then. Let's just zoom down a bit, see if there's anything else. I've got something else there covered in heat shrink, I don't know what that is. Ah, metal oxide varistor, I can see something written down there, MOV1. Couldn't be that conductive glue or something, could it? Because I remember I seen some glue on, I think it was a JVC appliance that I looked at. I think it was a little stereo, and it had this glue which had kind of gone conductive after it dried out. So I was wondering whether that could be causing any problems. I'm going to take this capacitor out and see if we can have a bit better look on this chip under here. Just see where the wires go on this one. Looks like they go from, I think it's those two. Right, that's that one removed. Let's just test what this one measures. Again, not too far out of spec. Let's have a look at this glue on this board. See if we can zoom down a bit more. Yeah, because it's being, you can see there where it's soft. That's what it's supposed to be like. This has gone all like crusty and hard. I'll try a bit IPA on that. I don't think I can get a toothbrush in there to give that a clean. I'll try a cotton bud. I don't know if I can get the number on that IC. No, not without the microscope. Well, I can't really see anything else on this. So I thought I'd get this under the microscope just to have a bit of a closer look. And it looks like it could indeed be this glue that's gone corrosive and conductive. I'm just looking at the pins here on this IC, if I can get my little tweezers in somehow here. Just that pin there. Yeah, that's moving that. And that pin there doesn't look very healthy either. And also we've got some corrosion on the side of this capacitor here. I'll just get in. Just there. So I think that's the problem. I think what's happening is when this heats up, the metal's expanding here, and it's causing that IC, or the leg on that IC, if I can get the, just back in shot there, to expand and lift. That's about the only thing I've found so far. Like I say, those connections on that IC don't look very good at all. If we compare them to the ones on the top of the IC here, they look in a lot better shape. So I might remove this chip, clean it up to get rid of the conductive glue that's in between it, and then refit it. Right, I'll get the rework station out. Right, so I'm just going to add some flux first. I don't know whether to add some fresh leaded solder as well. I think I'll do that. Now let's get the rework station on it. Right, we'll just give that a bit of a clean up now with some IPA and a cotton bud. Might need a bit more persuasion than that. Right, I think I'll resolder that capacitor as well. Just zoom down a little bit with this. Right, let's have a look at this chip. See if that needs cleaned up any. And again, it's got this horrible glue on the bottom of it. Right, I think that'll probably do. I'll just give it a quick, little bit more, just to be sure. Right, that looks fine. I'm just going to clean these pads off and put some fresh solder on them, I think. And put a bit of flux on here, I think. It's just awkward to get the iron in. That's the angle I'm working at. There's not a lot of room on this. I'll just spin this around a little bit. Nice, let's get this IC back in place. And let's get some hot air on it. Right, let's give that a little bit of a clean up. And it's still a bit warm. Right, well, that looks a lot better. Right, we'll get these capacitors back on next, and then we'll give it a test. Well, I've just finished fitting all of the capacitors back in, and I've put the bit of heat shrink back over these two. And just give it a quick clean on the bottom. So let's get this back in its housing, and let's power it up. And I think I might just check the voltage on the output here, because this seems to be the output here where the two output capacitors are. So I'll just zoom out a bit and I'll get some mains wired up to this. Right, I've got the mains wired up. Let's just switch it on. And let's just see if we get any voltage on the output. Try and get in so you can see the test meter. We've got 7.8. It's a bit of an unusual voltage, mind. Right, let's switch that back off a second. Let's couple it back up to the screen now and see if we get any activity. Well, it's back up and running again now. But obviously we still don't know whether we've cured the fault or whether it's still got a problem. So I think what I'll do, I'll just leave it on for a while. And we'll see if it stays on or if it goes off again. Right, I'll come back to this in an hour or so. Right, so I've left the device running for about 10 hours now. And it seems to be working fine. So the display hasn't flickered or anything. I've came back and checked it a few times. It's still on, it's still nice and bright. Touch screen and everything's working, so I think that's what it's been. I think it's been that conductive glue causing a dry joint on that switching IC and possibly even causing, I don't know, like a partial short circuit. Well, it's definitely causing corrosion on it. So I think reflowing those pins on that switching IC's done the job. Right then, I think another successful repair on this one then. And we've got another underfloor heating thermostat controller here. It seems strange that I've just done one and now I've got another one. Now this belongs to the guy who organises our repair cafe, and he said, just, you know, is this any good to you for parts? But he told us what the fault was, so I thought, well, I'll have a look and see if we can repair it in any way. And what the fault is it's showing the incorrect temperature on the display. So I'll just couple some mains up to it and then we'll see what it's doing. There, I'll just switch it on. I'll just zoom down a little bit. So there we go. So it thinks the room temperature is 82 degrees. And I think if it was 82 degrees in here, I think I'd probably be cooked. So why is it showing the incorrect temperature? I'll just switch it back off a second and let's take it apart and we'll have a look inside of it. Now he seems to think that it's the NTC or temperature sensor that's failed. I'll zoom down a bit. And I guess that's probably it there. RT2. Interestingly enough, there's something marked here, RT1. So I don't know if there's two temperature sensors in here. It seems a little bit strange. Looks like I put a Holtec chip there, and that looks like the display driver because it goes up to the display here. And we've got another chip here. I'll just see if I can zoom down a little bit on that. And I can't quite make out the number on that one. And it looks like a CY8C20110. So I know this has got touch controls on the front, so I'm wondering if that's some kind of touch controller. And we've got a little backup battery there. And a crystal, so I wonder if that's some kind of real-time clock perhaps. So the question is, why is it showing strange readings? Let's get the test meter out and let's just see what the resistance is across this thermistor. And we've got about 77K. So I wonder if I go on here, I'll just get the hot air rework station on a second. Yeah, well that immediately changed when I added some hot air onto it. I mean, that's showing about 10K now. Let's just plug that in. Let's just switch it back on and see what it says now. And now it's saying E0. Right. Let's switch this off again. So I'd say it's recognising the thermistor there, but I don't think it's the thermistor that's the problem, especially with them having two thermistors here. Let's just see what this one does. Again, we've got similar readings on this one. So I'd say that one's working as well. I think I might get this under the microscope so we can get a bit closer view of it. Right, so I've got the microscope set up. And this is where the thermistor at the bottom of the unit comes in. And it goes up here. And it goes to this capacitor, this resistor, that resistor. And then the other line seems to disappear through this wire here. And where does this one go? That one seems to disappear through a wire. And it goes through a resistor and through a resistor. Now, interestingly enough, that's a 104, that's a 104. That's a 01B, and that's a 01B. So I wonder if there's some kind of common denominator between these. So let's see if any of those are ground. So well, that one's ground. So I'm just on the side of this can here. That one's not. Let's just go back down to here. Let's just try from here. Right, so that one's ground. So we've got a ground on this NDC, which is also the same as the ground here. And then we've got the value, the other side of the then we've got the other side of the NDC goes through this resistor here and this one here. And the other side of the NDC goes this. So I guess one of them, I would probably think the 104 is probably some kind of pull-up resistor, and then the reading goes through here and then off to the MCU, I would think. So I wonder if we're not getting power to the pull-up resistor or something like that. So let's see if those 2 points here are linked together. So that would be that 104 and that 104. And they are. Right. So I wonder if we're getting power to these 2 points here. It might be a bit tricky to try and test this because I can't plug it in. Because it needs to be plugged into the power supply there. Unless I use some jumper wires. Yeah, I think I might use some jumper wires. Right. I shall go sort out some jumper wires. Right, so I've got some of these wires that I was using for some Arduino projects. So what I've done is I've just plugged them into this connector here. And just plugged them onto the back of there just to extend this so you can actually measure some voltages while it's plugged in. And it's still saying 81 degrees. So can I get the meter in shot as well? I'll just zoom down a bit. Let's move this along slightly. I'm just going to try and see if there's any voltages. Oh, that's because I've just touched the control panel there. Well, we've got 3 volts there. Which would kind of be what I'd be expecting. So it is indeed getting power. So why are we getting an odd reading then? Actually, not just because I've just pressed something, I think. Yeah, so we're still seeing 84 degrees. Let's switch it back off a second. Let's just check we're getting continuity from this. So that one's ground. And this one should go up to this point here. And it does. And then it should go through this resistor here. So let's just check that. We've got 1K, which is right. And then it should go to the MCU. So and I'm fairly sure that those NDC values are correct. I mean, that's about 75k at the moment. And that one's about 75k as well. So I can't see both of those NTCs going faulty. There's definitely something not right here. Let's try taking this out of the casing. Let's just have a look just in case there's some, I don't know, liquid damage or something something that we haven't spotted yet. So there's not a lot on that side. It's just literally the 5 pads and the display, and that's it. Well, that didn't reveal much, did it? I wonder what's under this can. Let's see if we can get this can removed. I'll just go and grab the soldering iron. I'll just zoom down a fraction. looks like it's soldered here. I wonder if there's something like an ESP chip or something under here. I'll try some solder wick or something, I think. Right, let's do the same on the other side. Let's spin that round slightly. Right, let's see if I can see what that chip is. And it's an EM357, so not an ESP chip. Just have a little look around here just to see if I can see anything obvious. But everything all looks good. I'm just wondering if there'd been something like a dry joint going to the one of the pins on the MCU, possibly, from the thermostat. Let's see if we can trace this through to see where it goes. I might have to bring the microscope again on this one though. Right, so let's try measuring from this resistor here. And we'll see if this goes to this MCU, which I would have thought it would. Right, so that goes to that pin there. So let's see if we can see where this one goes to, which is this thermistor. And that one goes to there. Well, that looks alright then, because we're getting 3 volts to this side, which is the pull-up resistor. We're getting the signal from the we're getting the signal going through this resistor, which then goes off to the MCU. And we're getting the same here. So I just don't get that. It's just in case there was a problem there, but we're getting continuity from there to there. Well, I'm scratching my head a bit with this one. And that one was just a ground. Let's just scrape a little bit here just to try. Just to double check that we are getting a ground there. Yes. Let's just check the value of these resistors again. I'm sure 1K. That might be because we're measuring it through the thermostat. Let's just double check what this one reads on this side. Yeah, we're getting a similar sort of reading. What I thought I'd try is measuring the voltage on each side of these thermistors, just to see what voltage is actually going to the pins of the microcontroller. So if we just use a ground here, and I go on this side of this NDC, we've got 1.8 volts, and then that's getting pulled up by the 3.3 volts here, and it goes through this resistor to the MCU pin, so we're getting 1.8 volts going to the MCU pin. Now on this one, again, we've got 3.3 volts, and this is the NTC, so if we go on this resistor here, we've only got 0.5, and this is what goes to the MCU on this pin here. We've only got 0.4. So this is like the other side of the NTC. We've got 0.4, but yet we've got 0.8 on this one. So, and the resistance of those NTCs seemed out the same. So I wonder if it's this resistor here. I wonder if there's a problem with this resistor. I'm going to take this resistor out and I'll just try replacing it. I think that's what it might be. Right, I'll just switch this off a second. I'm just going to add a little bit of flux. Right, I'll just go and find a replacement resistor. Right, found a replacement resistor. Let's just see if we can get this on. I'll just solder the other side. Right, I'm just going to switch this back on and then we'll see what voltages we'll get there now. Right, so ground on here. Still only 0.4. So changing that resistor has had no effect. So I thought, well, I'll remove the thermistor itself to see if that has any effect on it, and it's still the same. We've still only got 0.4 of a volt on here. So that goes to the MCU through that resistor there. So unless there's a partial short on the MCU pin itself, or the only other thing I could think is this capacitor here. So I'm going to remove that capacitor and then just see if that makes any difference. I mean, if I just switch it on there, and we'll just go into volts DC, and I go onto this pin here, you can see we've only got half a volt, and if I go onto this one, you can see we've got 1.8, and that's with the thermistor disconnected as well. So there's definitely something pulling the voltage down. So I'm going to remove this capacitor next and we'll see if that has any effect. I'll just switch this back off. Just add a bit of flux. I'm just wondering if the capacitor could have gone partially shorted or something. Right, so I'm going to switch it back on now. And let's see if that's made any difference to the voltage. Looks like it's actually worse. 0.2. Just a thought. Are we getting continuity from here? Yes, we are. I was just thinking if there was a break in this track here that we couldn't see or something like that, or if this pad had broke away, then we'd get the same symptoms, but... let's try measuring the resistance between ground and that. So we've got about 170 ohms, that's on the I/O pin. And about 70k on that, but then again that's got the thermistor going into it. So that shouldn't be affecting it. So why are we not getting the voltage there? I don't understand why that voltage is getting pulled down. Three volts. It goes through 100k. And we've got 3 volts here going through 100k to that pin. And then it goes to the MCU through a 1k. I just don't understand why that's getting pulled down. Let's disconnect it from the MCU pin just in case that's got anything to do with it. .2. So I wonder if there's a problem with the MCU pin. That's the only thing I can think, because if that pin's pulling down, if there's, let's say, like one of the diodes or something gone in that pin, or if that pin's set as an output to low, then that would give the kind of... But this doesn't make sense. It definitely seems like there's something going on there with that pin. I'll put the thermistor back on, we'll just check what voltage we get there. Just add a bit of fresh solder on that one. Although I have just had that rather hot with the soldering iron, so that's probably why it's so low. I'll just give it a quick blast with some freezer spray just to cool it down a bit. So I'm not reading it says now. Well, that's strange because it's saying 30 degrees. I'll just show you that. It's actually saying 30 degrees on here, without the input going to the microcontroller. Actually 36 degrees. So that's not right. So I wonder if it's the microcontroller that's faulty. Or unless there's some resistor for the analog to digital converter. There's some voltage or something missing. Because some of them have got like a reference voltage. That's the only other thing I could think. So it's an EM357, I think it was. Yeah, EM357. I'll just have a look at the data sheet of that, see if I can find any other info on this chip. Well, this is very strange. I've refitted the resistor there, and I did have a look at the data sheet, and I couldn't really see anything about an analog input voltage pin. Because some of them have a voltage pin that's used as a reference voltage for the analog to digital converter, but I couldn't see one on this chip. This is actually a Zigbee chip. So I thought, well, I'll refit this resistor, and I'll just switch it on. And if I now go here, and we'll measure the voltage to here, oh, I want a volts DC rather, we've got 1.7, which I don't know why. It's like if we go here, we've got the 3 volts, like we did, and then we go to this side, we've got 1.7 now instead of the 0.5 that we had before. And the only thing I've done is removed and then refitted this resistor. And then if we're going to the display here, I'll just pull it in front of the camera there. You can see there we've got 20 degrees C, which is about right. So I've got no idea what I've done, but it seems to have fixed it. And that resistor was measuring okay. So I'm at a bit of a loss with this one, why it's working now. I think there's some intermittent connection or something somewhere. Right, so I've put it all back together. We'll leave it on test for a while and then we'll come back to it. Right, so I've left it for a couple of hours and it's back to 68 degrees now. What on earth? So we haven't fixed this. So I don't know what the problem with it is then. There's definitely some problem, but I still haven't found it yet. Let's plug it back in with the extension leads and we'll see if we can measure some voltages and that again. Well, that's typical. I plugged the wires in and it's working again now. It's the only problem with intermittent faults. You can spend ages trying to figure out what's going on, but if the fault's not there sometimes and there others, it makes it a lot harder. Right, I'm going to try and connect it back up the way it was, let it run again, and hopefully the fault will reoccur and then we can try and diagnose it. Right, so it started showing 65 degrees again. So what I've done is, I've just disconnected the NTC totally. Just caught one of the buttons there. And it's still showing 65. So if I unplug it just here now, and if I zoom down, you can see there I've just disconnected that leg. So it's not even connected. And the NTC, the resistance lowers as the temperature increases. So it thinks there's a low resistance here. So let's measure across this cap. And I'll just zoom out a fraction just to get the meter in shot. And we've got 18K there. If we measure across this thermostat, we've got 37. So there's definitely something else pulling this down. And the only other thing is the microcontroller. So I think there might be an internal fault with the microcontroller, because that's the only other thing that I found that seems to be connected to this line. But without a schematic, it's hard to try and trace everything. So what I've done, I've went on this point here, which is going to the microcontroller, and then I've tried, you know, just going around the board just on resistance, just to see if it goes anywhere else. And the only place I've found that it goes to so far is this pin that's in the microcontroller there. So if we measure the resistance on the thermistor here, I've got about 120k. If I go into the pin of the microcontroller, I've got about 18k. And it's kind of bouncing around a bit as well. So this resistance here is what's actually giving the off reading. And we've changed that resistor, we've changed the capacitor, and we've changed this resistor, so... And the only other thing I found linked to this pin, or linked to this resistor, is straight to the microcontroller. So that's the only thing I can think. Something gone a bit weird with the input of the microcontroller. So I had actually finished recording the video and I was busy editing it, and I thought, I'm not quite happy with this. I want to be able to prove that the microcontroller is the actual problem. So I took some drastic steps and actually removed the microcontroller. So the microcontroller is no longer there now. So let's measure the resistance now between here and that point there. See if we get 18 ohms still. And if you look, we're getting about 70 ohms now. And if I go into this thermistor here, we'll get about the same. Oh, just get that wire probe on there. So they're both measuring the same now. So let's power it up without the microcontroller on, and we'll measure the voltages. So I'll just switch this on. I'll just get a ground here. And we'll just go on to this point here. And we've got about 1.74 volts. And if we're going to this point here now, we've got about 1.8 volts, which is right. So removing the microcontroller has gotten rid of the fault. So I'm 99.9% convinced it's a weird fault in the microcontroller itself, because we're not getting that weird resistance reading now, and we're getting the correct voltages with the microcontroller removed. So even though this one's not a fix, at least we've diagnosed the problem and we know what the problem is. And to be quite honest, it's probably not worth fixing this. It's an old model now, and I don't even think you can get these chips available now. I think these chips are actually obsolete. I mean, you probably get them on AliExpress still or whatever, but yeah. Right, I'm going to leave this one there then. So, right then, if you enjoyed this video, please give it a thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.